Okay, so here we go with the second video for chapter 14 on ethers. Remember, as I told you at first, it's ether this or that. That's because when you're naming it, you alphabetically list each chain hooked to the oxygen. You change the ending of the chain to YL because it's attached to something, and then you end with ether. So if we take this one, we have 2 carbons and 2 carbons, and 2 carbons is ethyl, and we have 2 of them, so we go diethyl ether. This one right here has different chains attached to it. We've got a methyl group and a T-butyl, and with T-butyl we take the B, so B is going to go first, so T-butyl methyl ether. A lot of times they won't leave the space here, they'll just run it all together as one, but I'm separating it so that you can see. This one right here has a T-butyl and a T-butyl, so di-T-butyl ether. Now remember the T, or when you have sec, those are used like numbers, so you do the dashes. All right, so let's take these and see if we can name this. I'm going to leave this up for a second. Go ahead and pause the video and see if you can name these. And if you can, great, if you get the right answers that I do. This is real easy, and I think these ethers are fun. Okay, so if you haven't finished naming them, stop the video, name them. We're going to give you the answers now. The first one is diethyl ether. We already did that on the last page. This one is ethyl methyl ether because you've got 2 carbons on one side and 1 on the other. This one is ethyl phenyl ether. And this one has 2 phenols, so it is diphenyl ether. Okay, let's do this again, see what you can do. Go to pause the video. Coming back, here's the answers. Diethyl ether, I like that one, so I'm going to keep using it. It's been used a lot as in industry and that, so it's really an important one. Ethyl cyclopentyl ether and diphenyl ether again, just a different way to look at it. Now, just like we can put methyl groups on and alcohol groups on, we can actually do a -OR, which is a carbon chain group. This is called an alkyl-oxy group. When we have an alkyl-oxy group, we name it like this: methoxy, F-oxy, isopropyl-oxy. Okay, so you can name these coming off, and these are ones that you should be familiar with. So let's name some F-oxy groups coming off. Go ahead and number the chain. So on this one, we'd have a 4, long chain here of 4, with a chlorine coming off and an F-oxy group coming off. So we would name it 3-chloryl 2-F-oxy butane. Here we have an F-oxy coming off, and we have a bromine coming off, and we have a 1, 2, 3, 4 chain. So we're going to go 1 bromo 2-F-oxy butane. On this one, we have a 1, 2, 3, 4, and we have 2 bromines coming off and 1 F-oxy. So on this one, we're going to go 1, 4 dibromo 2-F-oxy butane. Same kind of naming system. We just are, instead of saying chlorine or methyl or ethyl, we use the F-oxy or the methoxy. So what are some properties of ethers? They do hydrogen bond with water, but not with another ether. That's different from alcohols. Alcohols will hydrogen bond with another alcohol. They're like alkanes. They're inert. They don't react with most things. They are flammable. Diethyl ether used to be used as a first general anesthetic in surgery. However, the problem was that it was extremely flammable, so anytime they lit a flame, they had a little bit of an explosion. So on the same path as alcohols, we have what's called thiols. And thiols are a sulfohydryl group. They're an SH instead of an OH like an alcohol, but they're still named sort of like alcohol. You know, it has an OL. We change it to thiol. The thi just means sulfur instead of oxygen. OL will just be oxygen, but thiol is sulfur. We can also do a disulfide bond like this. And these are stinky, okay? Skunks use thiol chemistry as their protection. Onions and garlic also give off thiols when they're cut. So let's practice naming some thiols. So here we have a 3-carbon chain, and we have a thiol on the end. So we would name it 1-propanethiol or N-propanethiol. Here we have a 1, 2, 3, 4 with a thiol, 1-butanethiol, or N-butanethiol. Here we have one that has carbon and the thiols coming off number 1 also. So remember, if it changes the ending, it comes before something that doesn't change the ending. So we named disulfides a little bit different. Look at this. This is dimethyl disulfide. So the disulfide comes last, and we name each side. So it's sort of like an ether in naming, but then we put disulfide at the end. So this one would be propyl 1-propanol, propan-YL, because it's got a triple bond, and 3,3 disulfide. This would be di 1-propanol and 3,3 disulfide. Okay, so polyfunctional groups are groups that have multiple functional groups and are very common in nature. So it's just not an alcohol, or just not a thiol, or just not an ether. It can have several things going on. So an example is a carbohydrate structure, such as glucose, typically has functional group at every carbon group. Even though some organic structures look quite complex with multiple rings on long chains, remember that the functional group or groups are what determine the chemical properties. So if we look at this right here, glucose, alpha D-glucose, we've got alkylic alcohol here, 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 here. So we have 5 of them. And we have an ether group. On this one, and this is what you're going to need to be able to do, is just circle and tell me what group is on there. So let's look at this. What group is on here? Well, I have an ether. I have a secondary amine, means the nitrogen is, actually I think that's primary. It's primary amine. Sorry, I messed up on that one. Should be a primary amine. A ketone, an alkene, and we also have a cyclic in here that I forgot to name. Okay, so we do have a cyclic. On this one right here, we have a phenol, an ether, an alkane, and a 3rd degree or secondary amine. And the secondary, and this should be primary up here, so just think it's 1. Just means how many carbon chains it attached to. This one up here is only attached to 1, so it should be primary. And we'll start the review with the next one.